Hey, Liquid fam, welcome back. Now let's solve 530. Minimum absolute difference in BST. So yes, the question is again pretty straightforward. You'll be given the root of a binary search tree, and you have to return the minimum absolute difference. And yeah, look at the constraint ones. They are given that there will at least be two nodes. And yeah, what does the minimum absolute difference mean? Of a given tree, you have to find the minimum difference when you subtract any two nodes. Yeah, again the question pretty straightforward. And yeah, it is given binary search tree, so there might be some optimizations which I'll do research and upload in the next video. But again, in this video I'll do the brute force way to do that. Yeah, it will be of time of n log n, where n is the number of nodes in the tree, and I'll be using level order traversal to first get all the values in the tree and then sort those values and then return the absolute difference. And I hope you know how to get the absolute difference. You can just take any unsorted array or sorted array. If it is sorted, then your life becomes easier, but if it is unsorted, just sort the array and check for the difference between the ith node and I minus 1's value. Yeah, ith index and I minus 1's index, and that will ensure that you will have the minimum absolute difference. So yeah, again let's go on with the best thing to do, which is level order traversal. Yeah, but you can again do pre-order, in order, post order, vertical order, any kind of traversal you want, mainly because you just want to get the values of the nodes rather than what level it is or any other extra unnecessary data. So answer array, and then yeah, let's shift up with level order, and let me do pre-order traversal over here. Yeah, pre-order is left root right. So yeah, how you'll do that? You'll have a stack, and then while stack or root exists, while stack exists, what you have to do? You have to go while root exists, it's not stack. Yeah, while root exists, stack dot the root value and go as left as possible, and then pop the top of the stack, which is root, and yeah, answer, append that value to answer. Hey wait, it is given a binary search tree, so there's no need for us to sort it also. If you do an in-order traversal, then you will already get the sorted array. Oh yeah, that was a very good optimization which I had not thought of beforehand. I just saw it now. Yeah, so again this is the negative information. Whenever you are given a binary search tree and you do in-order traversal, you will always get the sorted array. Yeah, I think I told pre-order that time. No, we are doing in-order traversal. Dot well, and then root is dot, yeah, and just print answer once, and let me return, I don't know, 1, just to check it. And yes, as you see, since are given to the binary search tree, your values will always be sorted. And so now the complexity went from O of n log n to O of n. I think that's the reason they gave it as a binary search tree, so that you would notice such small things. And yeah, if you did not know that in order would give you the sorted array, then you would probably do a level order traversal, and then you have to again sort it, which would result in O of n log n. Yeah, which is like not, it's not like it's not acceptable, but hey, whenever you can do optimizations, you have to be able to do that. So now declare result is equal to, yeah, result is equal to, don't declare it to be 0, always declare it to be float of infinity. Whenever you are searching for the minimum value, the result should be float of infinity, and whenever you are searching for the maximum value, the result should be float of negative infinity. And for I in length of answer, but yeah, don't directly do this, do 1 to length of answer. Result is minimum of result and answer at the position I minus answer at the position I minus 1, then you can directly return the result. Yeah, this should again theoretically work. And yes, yeah, it works. See, even I had not noticed that. It is given, since you are given a binary search tree, there is no need to do pre-order or anything. You can directly do an in-order traversal and get the sorted array itself. So if you do any kind of other traversals, then you will have an unsorted array, and to get the minimum absolute difference, you have to sort the array, and which will directly lead to some extra overhead or and all. So yeah, be careful of that. I was about to do, I think by mistake I told pre-order or something. Pre-order is root left right, and I'm obviously doing left root right, which is in order traversal. Yeah, be careful of, yeah, don't get mixed up with the kind of traversal symmetry. Just make sure that you know what traversal is what. And yeah, as soon as you do an in order traversal and binary search tree, you will get a sorted array. And then yeah, this code is pretty straightforward. There's no need for me to explain it. Let me just submit it once. Yeah, and it's pretty efficient. There are so many submissions with the same code, I think. Yeah, they are also doing in order traversal. These people are doing, yeah, this is the iterative code if you want. This is the recursive code if you want. Yeah, but yeah, you can do any kind of traversal to get the in order traversal. But the thing with yeah, this code is that the the actual space will be O of n, but what LeetCode does is that it does not consider the recursive stack memory as the stack memory used while recursion as the extra space, so it will be like I don't know, super space efficient or something. Yeah, if you check out the most efficient, the most space efficient code. Okay, in I think you can revert to the older version and you will get the space complexity of each code also. Yeah, you can do it like that, and yeah, as you see, whenever you use uh, recursive function, they are telling that it will not be considered as extra space. So yeah, that's why this is like really extremely space efficient. But my code, yeah, since it is iterative, they are telling that uh, iterative stack, this stack is counting as extra space. So yes, thank you. And again, be sure to read the problem statement properly. It's a binary search tree, and in order to traversal of binary search tree always gives us sorted values. That's the reason they give binary search tree. Don't make mistakes like me first, where I first tried to do the level order traversal, and yeah, it would also work, but it would obviously lead to extra overhead as you have to sort there also O of n log n. But when you do an in order traversal on binary search tree, since the array is sorted, there's no need to sort it again. And so yes, thank you. See you next time.